Good morning, students. Today we are going to see inductive effect. When a covalent bond involves two atoms of different electronegativities, the shared pair of electron is displaced towards more electronegative element. As a result, the more electronegative atom gets a small negative charge and other atoms gets equal small amount of positive charge. For example, just see this carbon chain. At the end of this carbon chain, there is electronegative atom chlorine is present. This chlorine is a more electronegative than carbon. Because of that, the electron pair which are shared in between this carbon and this chlorine is shifted towards chlorine atom. Because of that, these chlorine atoms got del negative charge. Because of this carbon generates del positive charge. Now this carbon pulls electron pair of this bond towards it. Because of that, del 2 positive generate here. So del 1 positive is greater than del 2 positive, which is greater than del 3 positive. It is important. This type of electron shift or displacement along a carbon chain is known as inductive effect. Inductive effect is a permanent and decreases rapidly as the distance from the source, that is chlorine in this case, increases. Now we are going to see types of inductive effect. Basically, inductive effect is of two types. First is negative inductive effect. If the atom or a group of atoms attached to carbon atom is such that it attracts the shared pair of electron towards itself, it is said to exert negative or minus I effect. The decreasing order of minus I effect of some atoms or groups is, so just see here, carbon attached with some group, that is G, where G can be NO2, it can be Cn, COH, like this. So NO2 have greater effect as compared to Cn, Cn have greater effect as compared to COH, COH have greater effect as compared to fluorine, fluorine have greater effect as compared to chlorine, chlorine have greater effect as compared to bromine, bromine have greater effect as compared to iodine, iodine have greater effect as compared to OCH3, and OCH3 have greater effect as compared to your phenyl C6H5. Second type of inductive effect is positive inductive effect. If an atom or a group of atoms attached to the carbon atom is such that it pushes electrons away from it, it is said to exert positive or plus I effect. The decreasing order of plus I effect of some groups is, so just see CH3 by C, it have greater effect as compared to CH3 by 2 CH, which is have greater effect as compared to your ethyl. Ethyl have greater effect as compared to your methyl. So all these groups exert positive I effect. Now we are going to see electromeric effect. It is a temporary effect which involves a complete and instantaneous transfer of shared pair of electrons to one or the other atom joined by multiple bonds at the requirement of attacking reagent. So just see, let any molecule AB, which is double bonded, A is double bonded with B. When we add some reagent, so complete transfer of this bond is takes place on your atom B. That's why it is shown with B negative. Because of that, A got positive charge. If we remove this reagent, reaction go backwards side. So in this case, B is more electronegative than your A. Electronegativity plays an important role in knowing the direction of transfer of the shared pair of electron to one of the atom. For example, this is the example of carbonyl group. We know that oxygen is more electronegative than carbon. That's why electron pair goes on your oxygen. So it is minus E effect of oxygen. In this case, this electron pair shifted on your this carbon atom. It is positive E effect of CH3 group. In a propylene, the displacement of shared electron pair is towards carbon atom, which is away from methyl group. This is due to the positive inductive effect of methyl group, which is electron repelling. Thus, electromeric effect is of two types. When electron displacement is away from a methyl group, it is denoted by plus E effect. So in this case, we see that this electron pair goes away from your this methyl group. That's why it is known as plus E effect. Why electron pair goes away from this methyl group? Because this methyl group have positive inductive effect. And when displacement is towards the group, it is denoted by minus E effect. Now we are going to see resonance or mesomeric effect. Sometimes it is found that a single structural formula cannot satisfactorily explain all the properties of given compound. In such a case, a compound is represented by two or more structural formula, which differ only in the arrangement of electron. It is important. None of the structural formula alone can explain all the observed property of the compound. The compound is then said to be show resonance. The various structure are called as resonating structure or canonical structure. This statement is generally asked for 1 mark question in exam. The true structure of molecule is not represented by any of resonating structure, but it is considered to be resonance hybrid, that is intermediate of various resonating structure. Just see the example of CO2 molecule. CO2 can be written like this. CO2 can also be written like this. It can be also written like this. These all are canonical forms of CO2. This is not the actual structure of CO2. They are canonical forms. The actual structure of CO2, that is resonance structure of CO2, is like this, which are shown here. Now just see this table. This table is very much important. For CO2, theoretical value for heat of formation, when it is calculated theoretically, it comes as 1463 kilojoule per mole. But experimental value shows that it is 1588 kilojoule per mole. The bond length, theoretical bond length, it is 1.2 Armstrong unit, and the experimental bond length which is found, the actual bond length which is found, it is 1.15 Armstrong unit. Why this difference comes? It is explained on the basis of resonance. Resonance is also called as mesomerism. Now, condition for resonance. Main condition for resonance, that is first condition, is the position of nuclei of each atom in each structure must be same. That is, change is only in the position of electrons. The number of unpaired electron in each structure must be same. Each structure must have about same internal energy. The contributing structure which involve separation of positive and negative charges are of high energy and hence contribute slightly towards the resonance hybrid. The greater the number of contributing structure, this point is very much important. The greater the number of contributing structure, the greater will be the stability of the molecule. The larger the number of bonds in the contributing structure, greater is the stability. Now, what are the consequences of resonance? In first, what consequences seen due to the resonance in bond length? The bond length of actual molecule is different that of any of contributing structures. For example, if a structure of benzene is written like this, so we can clear cut see this, in this both the structure there is alternate double and single bonds. So carbon-carbon double bond length is 1.34 Armstrong and carbon-carbon single bond length, it is of 1.54 Armstrong. But X-ray analysis of benzene show that all these 6 bonds all the carbon-carbon bond lengths are equal and identical, having value 1.39 Armstrong. So actual structure of benzene is like this. It is the canonical form of benzene. Because X-ray analysis confirms that all the bond length in the benzene have equal value, that is 1.39 Armstrong. If we written benzene like this, so there are 2 types of bond length. So actual structure of benzene is like this, not like this. These are canonical structures for benzene. This is the resonance hybrid structure of benzene. Stability. Resonance energy is defined as the difference between the actual energy of the molecule capable of exhibiting resonance and energy calculated for resonating structure. A resonance hybrid is a more stable than any one of the various resonating structure. The difference in energy between hybrid and most stable resonating structure is known as resonance energy. Resonance hybrid is more stable than any one of various resonating structure. It is the important point. So just see here, these two are canonical forms of benzene, and this is the resonance hybrid of benzene. When we calculate energy for canonical form of benzene, it comes as 2322 kilojoule per mole. But actual value, that is experimental value, which is found, it is 2232 kilojoule per mole. So this is a difference between calculated energy for canonical form and experimental value is of 90 kilojoule per mole. So this 90 kg per mole energy for benzene, it is known as resonance energy of benzene. In our next class, we are going to discuss difference between inductive and electromagnetic effect and some other points. Thank you very much.